Oh, welcome back to molecular spectroscopy. Uh, Molecular spectro. So, where we left is uh, we are deriving an equation that is Schrodinger wave equation, and we are using time dependent Schrodinger wave equation, and we are having h cross square by 8 pi square m into 1 by psi x. So it is curl square psi x by curl x square plus energy of a system, that is potential energy, and it is equal to minus h by 2 pi eta 1 by phi t into curl phi t by curl t. So this is our equation. Now let this equation is equal to some constant which depends upon on energy. So that means we have a system which is depending upon energy and quantum number. So it is principal quantum number. So basically we have to define the position of a system. So therefore we know it is defined by the quantum number. So quantum number, so it is principal quantum number, that means it is denoted by n. So it is minus, so h square by 8 pi square m into 1 by psi x, which is equal to, so wait a minute, so it is rather psi x, it is d square. Now we are specifying to d square psi x by dx square plus energy ux. So that means we have defined this thing, and it may be equal to some energy system, that is psilon n. So this n is a principal quantum number, which is we mentioned, it is a principal quantum number. So energy is a symmetry energy, so it is a symmetrical energy on which this system depends. Also the another equation, so that is minus h by 2 pi eta 1 by phi t into d phi t by dt, which is equal to, so it is n, and it is two equations. So we are having these two equations. So we have independent solution of these equations. Also we may integrate this equation to solve. So this is a Schrodinger equation, conventional equation. We can put the solution of this equation directly. Okay, so we need not to emphasize on this equation. So basically this is the new equation for us, so therefore we will have to solve this. So it is very simple to solve this. So let us solve this equation. uh, so let us solve this equation. Let us erase this thing, and now let us solve this equation. So we have solution of this equation. So very easily, so we can have this equation. So this implies, this implies 1 by phi t, it is d phi t, which is equal to minus 2 pi eta by h. So we are just reversing the order, and it is equal to this energy function, so it is n and into dt. So that means we can integrate this equation. So integration both sides, so integrating, will get log, so we d phi t by phi t, it will be equal to log, so it is log phi t, which is equal to minus 2 pi eta by h into En into t. So we are having the equation, or other words, so we can write here, so taking antilog of this equation, so we'll get, so it is phi t, which is equal to e to the power minus 2 pi eta En t divided by h. So it comes out to be a equation. So what we can do is, now we can put the value of phi t in corresponding equation to get the solution. So let us see what happens. So let us see, I will just erase this, and now we are coming closer to a first solution. So this derivation is very lengthy, so you have to keep in mind. So let us see what lessons. So we know one thing. So one thing we know, that is in previous lecture, it is this big psi xt. So xt, it is the function of this equation. So it is curl, so it is psi x phi t. So, or we can say it may be equal to psi x into e to the power this equation. So it is minus 2 pi eta by h into ent. So we have this type of equation. So particle in a box, we have a solution, so it is very easy solution. So we know this equation, so it is under root solution of psi t. So psi x, it is given by under root 2 by a. So it is sine n pi x by a. So we are having this type of solution for a particle in a one-dimensional box. So we can multiply this, it is with e to the power minus 2 pi eta by h into epsilon n into t. So that means we are ultimately finding the solution for this equation. So now energy of the system. So let me define. So energy, so if you clearly look at this energy, so this is particle, so En is given by n square by h square by 8 m a square. So I take, so let us define the probability function. So that means everything is in imaginary, and we are taking probability to solve the imaginary function to a real system. So we want a solution in the real system, that is why we take the imaginary part. So let us see what will happen if we look at the solution in the imaginary part. So in the imaginary part, so you just know, so it is psi into psi star. So remember the big equation. So that means if you multiply, so these are the equation, this is the equation you have to put. So that means if you put this equation, so it is psi x into psi x psi x, so it is star, so it is e to the power, so 1 is minus 2 pi iota by h into en into t, and e to the power positive, because in the complex conjugate system we take positive and negative iota, so negative become positive, so that means these two terms can be cancelled out, and the solution will become a simple function which is not dependent upon time. So that means this is the way we can have a solution of a Schrodinger wave equation. We can have a solution of Schrodinger wave equation. So this might be the result. So it is again happening. So this might be the result. No,